Welcome to section 7.4, Assessing Normality. In this section, we're going to focus on one big question. When is it safe to use the normal model to describe data? We've already seen that the normal distribution plays a big role in calculating probabilities, building confidence intervals, and running hypothesis tests. But that's only valid if our data, or at least the sampling distribution, is close enough to normal. Let's dig into how we assess that. Many statistical methods assume that your data, or at least the sample mean, follows a normal distribution. This assumption lets us use powerful tools like z-scores and confidence intervals. But here's the catch. If your data is extremely skewed or contains outliers, these methods can give misleading results. Imagine you're trying to predict the average damage dealt by players in Dark Souls. Some players deal huge critical hits, while others barely scratch. If the distribution is highly skewed, it might throw off your predictions, unless you've collected a big enough sample. The central limit theorem helps smooth things out, but it doesn't make magic happen in small samples. That's why assessing normality is so important, especially when sample size is limited. There are a few rules of thumb for deciding when it's safe to assume normality. If the population distribution is normal, you're golden. Even a small sample will behave nicely. If the sample size is 30 or more, the central limit theorem usually ensures that the sampling distribution of the mean is approximately normal, even if the population is skewed. But if your sample size is small, like 10 or 15, and your data is skewed or has outliers, that's where you have to stop and assess. Let's say you're looking at loading times in Minecraft. If your sample is small and a few players are on slow Wi-Fi, those outliers can heavily distort your average unless you've checked the distribution first. First tool in your toolbox is the histogram. It gives a quick visual sense of the shape of your data. Is it bell-shaped and symmetrical? Or is it skewed left or right? Is it bumpy with gaps or clusters? Imagine you're analyzing the number of diamonds players mine per hour in Minecraft. If most players get between 3 and 5 diamonds, but 1 or 2 players luck out and get 20, the histogram will show a long right tail. That's skewed data. Histograms help you spot these issues fast. For small samples, a clearly non-normal histogram is a red flag. Next up, the box plot, or the box and whiskers plot. This tool is great for quickly checking symmetry and outliers. In a normal distribution, the median is centered in the box and the whiskers are about the same length. But if your data is skewed, the box might be off-center and one whisker might be much longer than the other. Let's say you're tracking match damage in Apex Legends. If most players are dealing between 500 and 1,000 damage, but if you crack 3,000 or more, your box plot will show those high-end values as outliers, and the box will stretch upwards. Box plots make it easy to spot these deviations from normality. The most precise visual tool for assessing normality is the normal probability plot, also called a QQ plot. Here's how it works. If your data is normally distributed, the points in the plot will fall roughly along a straight line. If they curve away from the line, especially in an S shape, it's a sign that the data is skewed or otherwise non-normal. You might not always need this level of detail, but when the stakes are high or the sample size is small, the normal probability plot gives you clarity. You can think of it like Iron Man's heads-up display. The histogram is the radar, but the normal probability plot is the high-res scan. Let's walk through an example. Suppose you collect data on 25 Fortnite matches, tracking how long each one lasts. Your histogram is slightly right skewed, but not extreme. Your box plot looks symmetric with no obvious outliers. Your normal probability plot shows points that are mostly on a straight line, with a little deviation at the ends. Should you use the normal model to build a confidence interval for the average math length? Yes, because your sample size is decent and the data is approximately normal. This is a real world case of good enough normality. If the plots looked worse, big skew, wild outliers, strong curve in the normal probability plot, then you'd want to be cautious. Let's wrap it all up. You don't always need perfect normality, just good enough to trust your results. When your sample size is large, say over 30, the central limit theorem usually has your back. When your sample is small, assess the shape with a histogram, box plot, or normal probability plot. Slight skew or mild deviation, you're probably fine. Heavy skew or clear outliers, use caution or choose a different method. In short, assessing normality helps you avoid mistakes and make stronger statistical claims. It's like checking your armor before battle. Don't assume everything is working unless you've scanned the system.